Hello dear students, this is a video on the topology question solutions, and today I will do a tough one. So they have given this x equal to ABC, and these are the options. Topology defined, and which of the following is true? Is it a Hausdorff, regular, normal, or connected? Okay. So here in this regard, so let it be a Hausdorff. Let P equal to this given part. Okay, and so if we have it, so consider A and C belongs to X, then for any open set U and V, and for that A belongs to U and C belongs to V, but U intersection V belongs to phi. So options A and D are false, obviously, and S is a connected space. Okay, so suppose some phi are not connected, then this is a open sets G1 and G2 such that G1 intersection G2 is a null set, but G1 union G2 is X. So for this, but this does not match such open space sets in X. No. X. So the statement S is true. So obviously option C is correct. Let's go to the next one. So here we have R square with usual topology. Which of the following is true? So is it like AP, and this theta? So this process is very easy. Let it be A equal to 1, 2, B is 2 to 3. So A union B, yeah, union 2, 3. So here this is actually 1, 2, 3 it will take, and so 1, 2, 3. Okay, so now if we take this, so here in this case it will be, so 1 to 2, 2 to 3 union, so this is also into, so not equal to these two. As a relate another case, A equal to 1, 2 and B equal to 2, 3, but this time not inclusive. Okay, so A intersection B, this complement, phi complement equal to phi 1, this. So in this regard, directly we can write it as 1 to 2 intersection 2 to 3 to 2. So this is not equal to B complement. So P and S are surely true. So option B is the correct answer. Let's go for the next one. Let X be a compact Hausdorff here, topological space, and Y be a topological space of X, bijective continuous mapping. Which of the following is true? So you need to talk about the closeness and openness of the map. So X be a compact Hausdorff topological space and Y be a topological space. Okay, so let f of X to Y is a bijective continuous mapping. So for this, then F need not to be an open map or closed map. Okay, so obviously D is the correct answer.